All right, guys, welcome to Statistics. This is 3.1. We're going to be talking about means, medians, and modes here. So to start off, we're going to talk about mode and median. These are probably the ones that you have used the least in the past. So mode is effectively the most common answer or most common result you would get. So the way that I remember that is mode and most. So for instance, if I say, hey, how many animals do you have at like home? And I get people who say 1, 2, 3, 4, 5, 6, 0, 9, whatever, right? If most people say, let's say 8 people say 2, and there's a few people who say 1 or 0 or 3 or 4, right? 2 is going to be my mode, right? So it's always going to be not always, but typically a whole number, assuming the responses you are getting are whole numbers. So where that kind of gets used, because it's probably the one that people see, well, why would I use that? It's kind of weird. Let's say I'm building a house, right? I'd say, well, I want to sell this house, so I want to sell it to the most people possible. So I say, well, what's the average sized family in this area? Maybe I get, hey, the average house is has 4.374 people, right? Well, I'm not going to build a house with like 4.37 or 3.37 bedrooms in it, right? But I'd say, hey, what's the mode family size or mode number of kids in a family? And that's typically 2, right? The average number of kids is like 2.45-ish, but the mode is 2 kids, right? So if I make a house with 3 bedrooms, 1 for the parents and 1 for each kid, I'm going to have more people that are going to want to buy that because that's the most common size house which is going to be needed. So it's things like that when you're trying to like find what's going to fit the most people out of this situation. Now median is a measure of the exact middle value of all of the data in a population. So the big benefit of a median is it's less affected by outliers. So things that are really, really high or really, really low don't really affect a median in the same way which they would affect a mean, where we add them all up and then divide by how many there are. So a median, place you're going to see those most often in real life is going to be like real estate pricing, right? So when you try and buy or sell a house, what they do is they look at like 10, 20, 30 homes in that same area which have recently sold, and they find the median price for that particular area. Now, why? And say, well, this is probably a good place to kind of start for the value of your home. Why they do that is you could occasionally get some home in that area that is like one of those $10 million homes down by the river, right? And if you average those by taking a like mean of you add them all up and then divide by 10, that one $10 million home is going to make your average home price in Lake Middleton $2 million or something weird, right? So medians kind of help to take care of not having to worry about those outliers. I have here how we can find the middle position. You just take the number of options you have, add 1 to it, and then divide by 2, and you go to that number, assuming that it's already in order of least to greatest. Okay, so now let's go ahead and try one of these out. So I'm giving you this situation. So go ahead, pause the video, try and answer those questions, and then come back here. All right, so first thing that we need to do is organize the data from smallest to largest. That's typically the go-to place we want to start with most of this kind of data. So if we reorder it, it looks kind of like that. Then my median, if I find the number in the exact middle, well, I got 40 responses here. So here's the first 20 goes to 15. Then my second 20 starts at 15 through 20. So 15 and 15 are kind of tied for that middle. So I would average those two. So let's say it was 15 and 16. I would average it to be 15.5. But they're both 15, so my median is going to be 15. Now my mode, what's the most common? Well, that's 12, right? I got 10 things that are 12, right? So I'm getting a fairly different number for my median versus my mode, right? Then, so all of these are forms of an average. So if you're trying to figure, hey, I need to report an average, but I want it to be high for my own benefit. What companies will do is they will pick and choose. Do do I use the median? Do I use the mode? Do I use the mean, which we're going to talk about? Which one of those will make the average look higher if I want it to, or make it look lower if I don't? And that's one of the kind of deceptive tactics which you see, because technically a mode and a median are both measurements of an average. So I could say the average is 15 here, even though when you typically hear the word average, you would think the mean, which is what we're going to kind of cover next. So kind of keep that in mind. All right, so mean, and this is probably the thing you guys know how to do when you talk about average. When most people say the word average, they mean the mean, right? It's when we take all of the data, we add it all up, and then divide by however many things we are adding up, right? So if I want the average of 10 numbers, I add up all 10 numbers and I divide by 10, right? You've been doing that for quite a while. So that's kind of what most people will default to when they hear average. So that is why we want to be really clear. We will typically say average and we mean the mean. In this class, and to be kind of ethical, we will always specify mode or median if we're using those as a measure of an average. If we just say average and do not specify, it is a mean. That's how we're going to do it, because that's going to be the more ethical way to go about it versus trying to be kind of sneaky and use one of the others just to benefit us. And then we have some symbols that you're going to be seeing the rest of the year. Some of these you may already know, but some of those might be new. So the first one here is the sigma symbol. This is a capital sigma in Greek letters. It's also summation notation if you've taken that in other classes. So it means the sum of all of these things. So if I said this symbol and then x, it's the sum of all of the x's, right? If I said this symbol and then y, it's the sum of all of the y's. Right? That's what it means. This symbol here, where's my mouse? There it is. X with a bar on it. It's literally called X bar. As you're going to see, statisticians are not very creative when they name things. We call it X bar because it's X and it has a bar, right? What that represents is the mean of a sample, right? So if I get a random sample of 10 people and ask them their heights, I average them all up, X bar would be my average of that sample's heights, right? And then mu is effectively the same thing, but mu is when it is of the entire population. So that is the average of a population versus X bar being the average of a sample, okay? And that is, it looks kind of like a U with a little extra leg on it, right? It's pronounced mu. Think of a little cat saying mew, right? Other two variables, lowercase n is going to be the sample size, and we've used that already in the past. Capital N is the size of the entire population. You're gonna see that one far less, but these other four, you're gonna see those a ton the rest of the year. So it's kind of keep those in mind, keep those in your notes. All right. So now we have what's called a trimmed mean. So a trimmed mean is when we actually try and just cut off the top and cut off the bottom, and then we kind of average what is left. So again, why we do that, as I talked about earlier, one of the problems with taking an average or using a mean as the average is outliers can drastically affect things, right? If we have one piece of data in our sample that is really, really high or really, really low, that one value can drastically sway what our mean is. So we can do what's called a trimmed mean, right? We typically will cut off the top 5% and the lower 5% of our data. So we, again, order it from least to greatest. Once we are ordered, we then take off the top 5 and the bottom 5 and just look at what is left and then find the mean of that. So it doesn't have to be 5%. It could be 1%. It could be 2%. It could be 10%. But you're rarely going to see things higher than 5, because as you cut off more and more and more, your data becomes less and less useful. So 5 is typically a good place which you're going to see, because you can cut out the kind of extraneous, kind of really out there data, and still have most of what you are looking for in the middle. So again, our process there: cut off the top 5%, cut off the bottom 5%, and then average whatever's left. So let's try that out. So here is a set of data. It has already been ordered for you. You're welcome. So find the mean of this sample, and then find the 5% trimmed mean of this sample. So go ahead and do that, answer those questions, and then come back. Okay, so if we do that mean, we should get about 36, right? And then if you take off the 5% trim, since this is it's 20 values here, 5% of that is going to be 2, so we're going to take off the 5% from top and bottom. 5% of 21, so we take off the top one and the bottom one, so we're going to lose the 14. We're also going to lose that 80, right? Average those, and we're going to get 37.4, right? So then if I want to find the median before I trim it, right, it's going to be, well, it's 30 to 35, so that's going to be 32.5. Now what if I find that median after I trim it? Well, it's 30 and 35 are still in the middle because I just lost those outer parts, so it doesn't actually change that median. And that's kind of one of the things we're talking about here. So the median will never change depending on how much you trim off of it. And even if you trimmed off 45% from each side, you're just going to be looking at 30 and 35 and find your median. It's still at 32.5. So what your trimmed mean effectively does is it takes your regular mean and makes it a little bit more like your median, right? It's kind of that halfway point, because oftentimes we really want that mean, but those outlier data points can really kind of give us weird numbers, so we can do a trimmed mean to kind of help not have to worry about those outliers nearly as much. Okay, so what these tell us, again, mode is going to be the most common thing. It's the value which occurs the most out of the given set of data. The median is the value right there in the like middle. The benefit of the median is it kind of is not really affected by the outliers. And then the mean, that is our kind of default. It's probably the most useful and most commonly used one, but its biggest downside is those outliers. So one way that we can kind of try and remedy that is with a trimmed mean, or just go into a median if the circumstance would allow for it. Okay, last little bit here on weighted averages. So you've encountered and seen these in the past, maybe not in this specific way, but weighted averages are how your grades are typically done, right? For instance, when we calculate your grade in this class, they take whatever grade you get for the in-class time. That's 80% of your semester grade. And then they take a look at your final exam, that's 20%, so that's weighed 80-20, right? So how we do that is we take the sum of all of the data values times their weight, right? So that seems kind of weird, and then I divide it by the sum of all of the weights, which is typically going to be 1, but it doesn't have to be 1, so that's why we kind of specify that. So if you look here, here's an example of us doing that. If I have 20% of my grade is homework and 80% is tests and products, which is what this class does. If I get a 95 on my homework and 87 on my test, I do that 95 from my homework times that being 20.20 of my grade plus 87 times 0.80 of my grade. Do all that out, and then it's over 1, because 20 and 80% is 1. and then I would get, hey, my grade for the class is an 88.6. So, and that's the kind of process. Don't stress out about that. As long as you kind of get how this part works, that's all we really need for weighted averages. Okay, with that, here is 3.1 homework. We're doing 1 through 4, and 5 through 29, just the odds. I'll talk to you guys next time.